First, let's begin with a description of the equipment. On top of the workbench, we have the Venturi apparatus. The Venturi apparatus is comprised of a Venturi section connected to 11 piezometers. From left to right, the piezometers are labeled A to L, skipping the letter I. Next to each piezometer is a graduated scale. The valve on the right-hand side is used to regulate flow through the Venturi apparatus. Next is the weight measuring tank, which is located below the workbench. This tank is used to trap water flowing through the Venturi apparatus. The lever arm at the front of the tank is connected to weights. There's a handle at the front of the weight measuring tank. This handle is connected to a mechanism which acts as a plug to the tank. Below the tank is a water reservoir which is used to supply water to the Venturi apparatus. Now we will check that the apparatus is set up properly. First, make sure that the red valve is completely closed by turning it clockwise. Ensure that the piezometer levels are reasonably equal and high enough, but not off the reading scale. If so, please alert the teaching assistant. Now make sure that there's no air trapped in the piezometers. If so, gently tap them in order to remove the air bubbles to the top. Ensure that a weight of 9 kilograms is attached to the free end of the lever arm. This should comprise of the 7 kilogram silver weight and hook and an additional 2 kilogram free weight. Make sure that the weight measuring tank is unplugged by keeping the lever on the front of the tank in the horizontal position. Going into the procedures of this experiment. First, set the flow at maximum capacity by opening the regulating valve slowly. This is obtained when the lowest piezometer reading is about 1 centimeter. This should correspond to the reading of the piezometer at station D. Throughout the experiment, make sure that the water level in any piezometer never goes lower than 0 on the scale. Every time the flow is adjusted, wait for a few seconds in order for it to stabilize. Take note of this reading at station D. Next, we will set the flow to a minimum. Reduce the flow by closing the valve slowly, such that the difference between the highest reading at piezometer A and the lowest reading at piezometer D is about 2 centimeters. Now take note of the reading at station D for the minimum flow. Next, we will determine the intermediate flows. First, determine the difference between the two extreme readings for piezometer D. Then divide this difference by 3 in order to roughly determine the interval between the two intermediate piezometer readings at station D between the maximum and minimum flows. Record the piezometric head in all piezometers for this minimum flow from left to right. Next will be a description of the discharge measurement. Make sure you have a timer at hand. Look into the weighing tank and try to understand the mechanism of the stopper. By turning the lever on the front of the tank counterclockwise in the vertical position shown, the drain at the bottom of the tank will be plugged. Similarly, when the lever is turned clockwise in the horizontal position shown, the drain at the bottom of the tank will be unplugged. This is an actual demonstration on how to measure discharge. Now turn the lever counterclockwise in the vertical position and start the timer. After doing so, ensure there is no water leaking from the bottom of the tank. Turn off the timer as soon as the balance tips over. The time recorded is the time required to accumulate 9 kilograms of water. Remember to unplug the tank by turning the lever clockwise in the horizontal position so that no water accumulates in the tank before starting any more runs. Now adjust the flow to a higher discharge. Then record the piezometer readings and measure the discharge as previously described. Repeat the step for the remaining flow adjustments. After the last flow adjustment, turn off the flow completely by turning the red valve clockwise. This concludes the procedures for this experiment. The following procedures is for the startup of the apparatus. Make sure that the pump is turned off. If needed, add water in the bottom reservoir using a water hose such that 3/4 of the reservoir is filled with water. Ensure that the power cord is plugged into the wall. Make sure the valve of the apparatus is turned off by turning the red valve clockwise. Start the pump. Remove any air bubbles from the manometers by tapping gently on the manometer tubes. Make sure that all the manometer readings are high and approximately equal. If not, seek help from the lab technician. Check that the Venturi device is operational by increasing the flow and observe the pressure drop in the manometers. The pressure drop should look like the following. The following procedures is to shut down the apparatus. Now turn off the flow completely by turning the red valve clockwise. Now shut down the pump and unplug the power cord from the wall and stow it in a safe place.